The fight with technology will be like this only. Yeah? Okay, this is a angular width. So time being, I'll show by red color. This is a width of slit. This is what that beta this in, and this is what theta 1, theta 1. This is a D1, this is D2. I'll show on only one side, and this is the capital T. Let's get into the thing, that one. So what is beta? Angular width of central mesh. Shall I write only Cm? This should be equal to 2 theta 1, and we know theta 1 is what? Lambda by D. Already I derived from that. So this will become 2 lambda by D. This is angular width of central magma. What is the angular width of secondary magmas? You can call symbol gamma. Books, they used some other symbols. What is the angular width of secondary magma means B1, B2. That we have to take it. So the suitable diagram will be yeah. So this is, I'm not interested now, this D1. So now we are interested in distance between B1 and B2. Let me take it out all these things. Yeah, look at carefully. So this is what B1, no? And this is B2. If I do like this, what do I get? I get the angular width of the central maxima. So this distance is how much? Alpha 1. This is alpha 2. So shall we take difference of that alpha 2 minus alpha 1? We'll get the required answer. Alpha 2 minus alpha 1. Alpha 1 is how much? Alpha 2 is 5 lambda by 2d. 3 lambda by 2d. And how much finally? Gamma will end up with lambda by d. Can you say anything about beta and gamma? Beta is 2 times of gamma. So what is the angular width of secondary maxima? Twice of angular width of the angular width of central maxima is twice of angular width of secondary magma. This is what I'm putting. So angular width of central magma is 2 times of angular width of secondary magma. In case of interference, what will happen? All magma, central magma or any magma will have same width, but here it will be different here. So for the width here, it matters here. And what about the minimas? Will be same. Angular width of secondary maxima or minima, both will be same. So I'll write it separately here. Angular width of secondary maxima is in fact equal to angular width of secondary minima. Okay, this is all about how to get the positions. Everything we have brought it here. So I am more interested in this one. Angular width of secondary minima depends on what? Depends on width of the slit. So if I vary the width of slit, what do you say? The angular width will decrease, no? But according to practically, if I vary the width of slit, means as I increase width of slit, so what do you guess? the angular width of secondary maxima will decrease. But practically, if you go on, if you keep on decrease, if you keep on increase at one particular point, the secondary maximas, minimas will disappear. I think the mathematics is not helping us here. I'm putting one very good statement. All of you do listen. As I keep on increase the width of slit, this width will increase. Then what will happen to the angular width of secondary maxima will decrease. At one particular width, the secondary maxima itself will disappear. What is the impact of what is the impact of the slit width on the central maxima? So as you increase the width of slit, what will happen to the central maxima, angular width of central maxima? It will also decrease here. Okay, is it clear? It will also decrease here. So I'm more interested on this than this one. I'm more interested in this one. So as you increase this width, this will also decrease here. I'm more interested on this one. Let's focus on this one. Okay, now let's get into the original concept, why we are studying